Hi guys, again this is Shopriya Mukherjee from SupNet classes. Today we will discuss about some problems in chemical equilibrium. In this session we will be discussing just one problem on chemical equilibrium because we always believe that small doses of medicine gives you the right requirement and not heavy doses. Sometimes heavy doses of medicine cause some overreaction and some more problems. So just one problem for today from the chapter called chemical equilibrium. So this is a very easy problem which we will discuss today. This will not involve much of complicacy, but obviously this problem which I have selected will help you to understand the basic concept for solving problems on chemical equilibrium using the knowledge of stoichiometry. So let us jump right into the problem. So what does the problem statement say over here? 2.94 moles of iodine and 8.1 moles of hydrogen are heated at 444 degrees Celsius until equilibrium is achieved. 5.64 moles of hydrogen iodide is formed or hydroiodic acid is formed. Then we have to find the equilibrium constant. Now all this reaction has happened in an 1 liter bulb. So this is a very important statement that all this reaction has happened in a 1 liter bulb. So you have to remember this one. All this reaction has happened in a 1 liter bulb. So you have to keep this thing in mind because this will be a very key parameter while we solve this problem. So first of all, for any chemical equilibrium problem, our first criteria, if the problem has not come with the reaction, then we have to write the reaction. So this is a very easy reaction. Even if sometimes they don't give the equation, it is expected from a class 12th pass or 11th pass, even 10th pass student to write this equation by themselves. So as we will be solving a problem on chemical equilibrium, it is very much obvious that it will be a reversible reaction. So H2 plus I2 gives 2HI. So the equation is balanced. First, what we have to write over here? So basically, to find the equilibrium constant, if we first think what is the formula for the equilibrium constant, it is basically the concentration ratio where we multiply the concentration of the products raised to the power of its number of moles that is reacting divided by the same of the reactants. But all these things which we calculate for finding equilibrium constant, we have to take at equilibrium. So that is a very important parameter once again. So if we have to find the equilibrium constant, it shall be at equilibrium. So first, what we have right in hand? It is given in the problem that is there is 2.94 moles of iodine and 8.1 moles of hydrogen that we have in our hand when the reaction has not started. So I write the equation, and initial I write 8.1 moles, 2.94 moles, the reaction has not started, so I am not expecting any moles of hydroiodic acid to form. So this is 0. Now I assume that X moles of hydrogen has reacted. Okay. So if X moles of hydrogen has reacted, now let us forget this 8.1 and 2.94 for a minute. X moles of hydrogen has reacted. Then how many moles of iodine will react with X moles of hydrogen? Here we can see 1 mole of H2 reacts with 1 mole of I2. So X mole of H2 will react with x mole of I2. So that's what I have written. This is pure stoichiometry, nothing else. X moles of hydrogen has reacted, that I have assumed, and so x moles of iodine will also get reacted. Now if x moles of hydrogen has reacted with x moles of iodine, then how many moles of hydroiodic acid will form? Again, if we see, 1 mole of hydrogen reacts with 1 mole of iodine to form 2 moles of hydroiodic acid. So x moles of hydrogen reacts with x moles of iodine, it will form 2x moles of hydroiodic acid. So this is very basic, but a knowledge of stoichiometry is required to get to this point. Now what happens at equilibrium? At equilibrium, x moles has reacted, so 8.1 minus x remaining, 2.94 minus x remaining, and here what has been formed? 2x moles of hydroiodic acid has been formed. So 2x mole is important over here. Now let's come a little bit down. So now I got all the concentration in terms of x at equilibrium. Now in the problem statement there is another value given, that is 5.64 moles of HI is formed at equilibrium, right? So at equilibrium what is the amount of HI has been formed that I have calculated? 2x, and in the problem it has given that 5.64 moles. So 2x is equal to 5.64. So what is x? X is equal to 2.82. So as soon as I find x, I can easily calculate at equilibrium how many moles of hydrogen is remaining, how many moles of iodine is remaining, and how many moles of HI is formed. Directly HI formed is given 5.64, from where I have calculated the x, so it will remain as 5.64. Now x is 2.82, so 8.1 minus 2.82 will be 5.28, and 2.94 minus 2.82 will be 0.12. Now all this reaction has happened in 1 liter bulb. So basically all the moles we are talking about is basically moles per liter, unit of concentration. So we already know what is the Kc formula. Concentration of the product raised to the power of the number of moles of product that is formed as per stoichiometric equation, divided by concentration of the reactants, product of concentration of the reactants to be precise, raised to the power of number of moles, but here the number of moles is 1 and 1, so nothing shall be done over here. So I just put the values and I get the value of equilibrium constant as 50.2. So for this problem we used stoichiometry, we used another concept, that is the Kc formula will consist of the concentration at equilibrium. So basically we have used 8.1 minus x, 2.94 minus x, and 2x. We did not use 8.1, 2.94 or 0. So these two concepts are required while solving this problem. Thank you. From Supnit classes, we'll get back to you again with some more problems on chemical equilibrium in small doses. Best of luck. Thanks.